Hello, friends. I'm Vicente Herrera. Welcome to the channel This is Exponential. I'm here with Lovkush Agarwal. We are going to talk a little bit about AI safety, AI alignment, and obviously anything you can tell us about your career, your progression, and what advice can you give to other people, and what can we learn from you? Okay. So first, please present yourself a little bit about what you have been doing. What's your career about?
Yeah, sure. So, my name is Lovkush, and my career hasn't been totally direct. So, I started off by doing a maths undergrad and master's. I enjoyed maths, and most of the people I talked to at the time said avoid working for as long as possible. So, then I continued to do a PhD in maths. I enjoyed doing the research, it was fun,
Mhm,
but I actually enjoyed the teaching side more than the research.
mhm,
So, then I taught maths for a few years after my PhD. Um, and although I was pretty good at it and I enjoyed it a lot, there's various little reasons, no single reason, but various little reasons added up that teaching wasn't a great long-term career.
mhm.
In the background, I had been interested in machine learning and data science. It's hard not to be if you're a technical person. So then I moved into data science. I was a data scientist for a few years. And then I think the main trigger was the rise of GPT and other big developments. So I was aware of the effective altruism community. I was
Mhm.
aware of X risk. I was aware of AI safety, but I never chose to move into it. But I think with the huge developments in the past couple of years, I made the effort to transition. So the big turning point for me was attending a boot camp called ML for Good. So I attended the boot camp in March 2024. Last year, we can say that now. And since then, I have been doing various little projects, mostly around field building. So I met you via BlueDot. I'm a facilitator
Mhm,
on BlueDot, which helps introduce people to the core concepts of AI safety.
mhm. BlueDot, are you saying? Isn't it? Because I think the connection garbled a little bit there. Yes. And as a disclaimer, I met you as a facilitator in BlueDot for the AI alignment course I myself are following. And you were helping my cohort for a session, I think it was, isn't it?
Yeah, that's right. So we first met via BlueDot. I covered one
Mhm.
of the sessions for your cohort.
Mhm. Let me ask you a couple of questions about your career, because I know several mathematicians and physicists, and I myself started studying physics and transitioned to computer engineer. But I have many friends that are physicists. They completed the physics course. It seems that you are people very versatile. It's like you have done so hard things already that any other thing that you can think of as, oh, let's look into this thing, and it's going to be easier than math anyways. Isn't it? Like
Ah.
research and math sounds difficult, isn't it?
It's an interesting one. So somehow it is the case that the skills you learn as a mathematician or physicist generalize to a lot of other fields. I haven't actually thought deeply why that's the case. One thing I have previously thought is it's interesting because mathematicians and physicists they study things where it's possible to get the answers, and so in some sense it's very simple. It's like, oh yeah, it's a very well-defined system. We remove all the complications necessary so we can answer the questions. And somehow those skills do generalize to other fields. So
But
when I, for
I
example, imagine an economist, it's like, well, they're dealing with the real world. It's like they're actually answering the really hard questions, and that's why there isn't such a solidified theory like there is in maths and physics.
maybe that's the way. Uh, I am thinking maybe in engineering you tend to add things to solve something, while for what you are describing, mathematician tries to remove things to try to reach to the truth and solve a problem. And that way it may seems easy for you, but maybe it's the path of taking out all those layers and simplifying things which is hard. And I find many
Uh,
times people struggle with complex problems because maybe they need to practice that skill?
That's an interesting one. So it's possibly something I take for granted. This is something I noticed, for example, when I was a data scientist. Like amongst my teammates, I would always try to abstract the problem. So remove all the domain-specific problem. It's like, we have a table of numbers, and we're trying to predict another column of numbers. And that's usually how I think about the problem.
Well, I would ask also as a data science, because right now, the world of machine learning, let's say, I see a career path where you can be a software engineer and somehow get into machine learning. But then there's the definition of data science that is more like a scientist. And as you say, maybe more in the background of mathematics and physics. Do you see these two paths being very different? Or do you have very different mentalities, maybe, that a software engineer? Or do you think it's possible for a software engineer to end up being a data science at the end of their career?
Again, it's hard to say because I probably take a lot of my skills and mindsets for granted. In my mind, it should be possible for a software engineer to move into data science for sure.
Mhm.
There will be, it really depends on, how comfortable you are already with sort of a researcher mindset, critical thinking mindset. There isn't a lot of big ideas or big complicated ideas, but as long as you're able to just think, how do I know what I think I know? Is this experiment proving what I think it's proving?
But it's interesting because I think the key is what you're saying, research mentality. And I think that's one thing engineers, me myself, don't get a lot of training on practice. Like we are presented the like this is the ground truth of how the world works, because physicists and mathematicians tell us so. They have think a lot about this, and this is the math that works for this problem. And we're not so used to research things like in a very abstract way, and more on, hey, these are the bricks, the Lego bricks of what works. Now use all these bricks to put something together, maybe.
I'm not sure. I think software engineers will have some of the requisite skills. Okay, if you're deploying a product, you need to have a sense of how do I know the code is doing what I'm doing. Okay, and you have the whole framework of unit testing. And so you do have some kind of scientific researcher mindset. Like, you have someone who just deploys code.
Obviously, to be solving problems, isn't it? You have to think a little bit about that. Yeah. Well, I ask all these questions because I think people that are studying right now in the university, and there is a lot of now potential work in AI, in data science, a lot of interest. Maybe the need was already there since a long time ago, but now like it's cool again. Like the fashion is to say that your company is looking a lot into data, into AI. So people that were not trained a lot into that are now saying, oh, maybe I should be looking into how to work there, isn't it? So all these advices, I think, could be useful for them to say, hey, you really can get into this. You just have to train yourself in, get advantage of opportunities that you have to do specialization courses, isn't it? And having this mindset. But an engineer, as a mathematician, as a physicist, should be able to do it also, isn't it?
Oh, for sure. If you have a STEM background, moving into AI or machine learning is very, very accessible. Even if you don't have a STEM background, it is still possible because, again, machine learning, AI are relatively young fields. You don't need a huge amount of technical knowledge to start to understand it. Okay, it's more, so if you stop doing maths when you're 16 years old, it will be a steep learning curve. So I'm not going to say it's easy, but especially with the advent of the current LLMs, anytime you have something you don't understand, there's a very high chance you can just ask Claude and it'll help you better than any tutor you've probably had in your life.
Yeah.
It's getting to that stage. So if you're STEM, it's very easy, I would say, to move in. If you're not STEM, possible,
Okay.
especially with the aid of modern AI tools.
Very good. So let's talk a little bit, for example, about BlueDot and the kind of training they provide. as I mentioned, I myself didn't know much about it. To be honest, I saw an Instagram ad about the AI alignment course, and that's the way I enrolled it. And then after that, I realized, they were doing a lot of things, several other different courses, and the how their mission is more like a mission to try to make the world better. Let's say that's the way I put it together. What's your how has been your experience with BlueDot? How did you get to learn about them and join them?
Okay, so as I mentioned very briefly before, I'm familiar with the effective altruism and rationality communities. And in those communities, AI safety has been a topic of concern. I don't know when, but at least for several years.
Mhm.
And so I actually took a very early version of the Blue Dot course, I think
Oh,
almost 3 years ago now, before it was even called Blue Dot. And so I guess that's how, in some sense, I learned about it. Now, how did I find out? It must have been via 80,000 hours. So
mhm.
80,000 hours is an organization that uses principles aligned with effective altruism to give career
Mhm.
advice. And I think I went through one of their guides. AI safety was a natural fit for my skill set. And then taking this Blue Dot course was a recommended next step. So that's how I first encountered it. That was 3 years ago now. But then in August or July last year, because I should say my final day at work as a data scientist was July last year.
Mhm.
And so I was trying to look at what opportunities there were. Given my teaching background, facilitating made sense. And again, I think a friend was the one who recommended it. It's like, oh yeah, you've done Blue Dot, you like teaching, you should try facilitating as well. In terms of my experience with Blue Dot facilitating, is that
Mhm.
something you'd like to know? Or
Yeah, please.
I think the biggest thing I've learned is just how many people of a huge range of backgrounds are interested in AI
Mm.
safety. Uh, Not just technical people. So I run 4 cohorts, and 2 of them have been completely non-technical. And even in the
Mhm.
non-technical side, there's a lot of nuance in terms of background. We have some people studying psychology or cognition. We have someone with a background in sales. We have some people who are already involved in policy in some capacity,
Mhm.
but not on the AI side. But okay, they feel like they want to know about it and maybe transition. So that's the biggest thing I've learned.
Mm. I agree with you. In my experience, also, I find a mix of people with very different backgrounds, and I think that's pretty good because that's something I also tell people many times when I hear discussions about AI safety and such. That I always say we need a mixture of different kinds of experts. You can't just go to engineers because we don't have the whole picture. We need a broad range of people with a lot of different backgrounds to be able to study these problems. Let's talk a little bit about this, about AI safety, alignment. One thing, I wanted to ask you to define for this video is AI alignment in particular, because uh, I was involved in AI security, let's say, since a year ago, and I wasn't really aware of the concept of AI alignment, and this is something that was really interesting and useful for me to learn in the course. Could you explain to me, like in simple terms, what is alignment?
So what is AI alignment? So I
In
don't
your
think
own
there's
words, doesn't have to be super.
a
It's not like
yeah,
a test. It's just for plain people that wants
yeah,
a
sure.
brief introduction, even if it's inaccurate in several places.
Yeah, so I want to say I don't think there is any official definition, and I think that's in some sense reveals a part of the problem. But okay, in short, AI systems are going to get more and more powerful, more and more capable, and there are reasons to believe that if you give the AI system some goal or some instruction, it might not do exactly what you actually intended it to do. So it might take your goal very literally, or it might not consider some things that you thought were obvious and don't need to be said, but
Mhm.
somehow the system doesn't take that into account. A shortest way to say that the system is aligned is a system is aligned if it tries to do what you actually want it to do. Even taking into account that maybe you didn't say exactly what you intended.
It's I think it's a good summary. Let's try to put an example for people. Like if I have a artificial intelligence, I have a company that is helped by artificial intelligence system, and I tell the system, okay, I am selling food to people. How can I improve my profits? And maybe the system will say, oh, it's very easy, just sell food that is that people is unable to eat because it's super cheap. Just sell, I don't know, wood scraps or things like that as food, and you will be rich. And you say, well, obviously I meant to be not to make people sick for what I sell, isn't it? And this drives me to one thing that was studied that I can ask you also about, the difference between inner alignment and outer alignment. When how would you describe the difference of these two things?
Okay, so this is getting pretty subtle. Again, a
Yeah,
caveat is
I myself sometimes have to stop think about this, because for me, well, everything could be at some point outer alignment, because if you specify everything super well, shouldn't be any problems, isn't it?
yeah, so a very brief description, and some people even question whether it's a useful distinction. So outer alignment is very roughly, can I give instructions to the system that actually do match what I intended in my mind? So, and again, maybe it's like, oh, can you help me lose weight? Maybe I'm saying this. And obviously, human context means that, okay, can I lose weight in a healthy way that doesn't harm other people, etc., etc.,
But it's
etc.
not going to kill me, because I will lose a lot of weight if I die.
Yeah, that's like a pretty extreme version. It's like, oh yeah, if you just, if you just die, then you'll lose a
If
lot of
you
weight.
just kill yourself, you will lose all your weight.
So that seems like a pretty.
I think in the past, several strong drugs like cocaine were recommended to lose weight, for example, which is obviously known to be now a bad advice. But even in the past, doctors were recommending things like that. So it's something that even humans struggle to solve well. So it's not something that's for granted that the AI is going to know exactly how to do perfectly since the beginning, isn't it? So that would be outer alignment, isn't it? When you don't specify exactly all the details. What
Yes.
about inner alignment?
So inner alignment is a lot more subtle. It's we have to go into a little bit of the details of how machine learning works. So
Let's do it. Let's do it. Let's have
in
fun.
most
Oh, a
machine
ghost.
learning
Yes, pass it.
in most
So,
machine learning paradigms, the standard vanilla framework is you first do a bit of training, you observe how well the machine performs. If it performs well enough, you then deploy it and make use of the trained system. That's the vanilla framework. So do some training, look at its performance. If it looks like it's doing well, deploy the system. So now, a very classic example is to illustrate inner alignment is, let's suppose I train a system to navigate through a maze. And then on all the examples, it looks like the system successfully gets to the end of the maze. It's like, oh yeah, look, it's getting to the end of the maze every time. That's great. And then we deploy it, and it turns out that, for some reason in the real world examples of mazes, it's not trying to exit the maze. It's always heading towards red objects. And you might be like, okay, why did that happen? The reason this might happen is if in all of your training examples, your goal is correlated with something else, which you're not aware of, there is no way for your paradigm to guarantee that the machine will learn what you actually wanted it to learn instead of some correlated goal.
I see.
So
I remember one case where they were describing a system to detect tumors on X-ray scans for lungs, and they thought they trained very well a system. Well, in fact, the system was trained to detect a ruler put on front of the X-rays, because anytime somebody had a tumor, they put a ruler to measure the size of the tumor in the picture. So the ruler was in all the pictures with people with tumors. And what the people, now the system was doing exactly what it was told. It said, these are pictures of people with tumor. Let me know if somebody has a tumor. And every time every time a ruler is in front of the picture, that means the person has a tumor. So that's what they're going to learn, isn't it?
yeah, I would say that's an excellent example of a real life use case where, as far as you could tell in the training, it's like, yeah, the machine always predicted correctly that there's a tumor. And then when you go to real life cases, it's like, why is it predicting nonsense? And then you just have to imagine how much more complicated this can get with more powerful systems or more general systems.
Well, let me ask you another more or less open-ended question, because I started myself looking into AI security, which is cybersecurity mostly. There is like a 99% cybersecurity, plain cybersecurity. Then I was reading about AI safety. Now I am learning about AI alignment, and I'm mixed about all these things. And would you consider yourself that AI alignment is part of AI safety? And I see, for example, that AI security is part also of AI safety as a point, or are there separate things, safety and alignment?
Yeah, so once again, terminology won't be 100% consistent amongst everyone.
Well,
but
your
at least in my
opinion,
opinion, in my opinion, AI safety is the broader term. How do we make sure AI is safe? How do we make sure it works for humanity? And AI alignment is just one of the necessary inputs into AI safety.
It's one part of the whole set, isn't it?
So, for example, even if we did have techniques which are reliably aligned AI, we still have questions like, okay, how do we make sure that people use those techniques? We then have questions like, okay, which people do we align the systems to? Okay, because we can have bad people. It could be aligned to a bad person trying to do bad stuff. How do we prevent those kind of problems? And then there are even problems where maybe just having lots of AIs in society, which are all aligned, could create unexpected, unstable scenarios. Because again, like, who knows, if you have millions of AIs all just interacting in the world, maybe there's some brittle situations where, they all fail in some unexpected way by accident.
That's interesting. Let's talk a little bit about situations like that. And I think now that's when we can have fun about thinking, scale things, science fiction scenarios, or maybe not so much. Maybe they're realistic, super realistic. We are, Sam Altman is saying that they know how to do artificial and general intelligence that we could define as an AI that is as capable as a human to process and solve and research on its own things. That may lead to the promise of artificial superintelligence that may be defined as the AI improve itself then in a way that is beyond what we can do. And by the way, it's one of the motivation of the name of the channel. This is exponential. It's like when AI will train itself in a way or improve itself, learn to perfect its own data somehow, its own algorithms. Maybe the outcome will be beyond what we understand and what we can know how it works. So all this work that all this research right now for safety and alignment might be super important in the future when AI it's maybe improving on its own, and that's something that was opening my eyes in this BlueDot Impact course that I wasn't thinking a lot about. I thought, well, this is maybe beyond we could research. But it's a real problem that people are researching, isn't it? And that it's in the mind of people thinking about these problems. What's your opinion about this scale problem of AI safety?
And when you say the scale problem, you mean will solutions
AI
that work?
getting, how AI getting more and more complex. The more complex it is, the more difficult it is to study it. So some people say we should limit how powerful AI could be. Some people say we should make sure it's safe now in a scalable way, so we know that it will scale upwards in a good way. Some people say there's no problem, that a super intelligent AI will know what is better to be doing anyways, or that we should just let the industry find the solution by its own when they are building the systems, and we shouldn't care too much if we are not the ones developing AI ourselves. These are different things I'm reading about. By the way, I was for example reading your blog article about the Athens meeting that was discussing about AI safety. Was it on January?
So I think the meeting was in December. So
Oh yes,
I attended for a couple of hours, but there's a group called the Future Society, if I remember correctly, and they've been hosting various roundtables. This was the 6th edition of the roundtable, and it was collecting stakeholders from various different parts of society, both from the policy world, from the technical world, also from civil society as well. So, and the 2 hours that I watched, the introductory sessions, was just a way of dozens of people giving their 1 or 2 minute summary of, okay, what are their current biggest concerns about AI? What do they think should be taken into account in the later discussions in the afternoon, and also just in all the future policy discussions that are happening right now?
So what's your opinion about those conversations? What was said? For what you saw, do you think they are providing good information, or they're losing track? What's your idea about what's happening?
Okay, so what do I think? So there's 2 or 3 little things I would say I took away. First is, it's great to see there are a large range of people from a large range of backgrounds, again, paying attention to AI and thinking about, okay, how do we make it work? So that was definitely very encouraging. Second thing that really stood out is it's going to be pretty challenging to find policies and frameworks that satisfy this large range of different preferences and focuses. So on one hand, you have people who are worried about the very short-term risks. So, AI systems can create or exacerbate biases in human systems, or AI can maybe help proliferate misinformation. So those are the short-term risks. People are already very conscious of those. And then you have people on the other end who are very worried about the tail risks. Can AI take over? Can AI make humanity, lose its power, and in even the worst case scenario of extinction? And it is sometimes jarring to see 1 or 2 people bring up extinction, and then other people talking about the short-term risks. So there's clearly even just misalignment amongst the people in the room about what is the
what's the correct path, isn't it?
What's worth focusing on? Which risks should we care about? My high-level opinion is a lot, not necessarily all, but a lot of the short-term interventions will help all the risks in a similar way. Not necessarily everything, but that's my high-level impression. So, let's just try to check, what are the models capable of? Excuse me. Oh, let's just check. If it looks like the model is capable of doing something we don't want it to, we should have mechanisms in place to reduce, how widespread the model.
Yeah, the impact of what's going on, isn't it? Very interesting. uh, where do you think? And by the way, I'm asking these questions trying to help you, but if there is something specific you want to tell me, let me know. Okay, it's just
Sure.
I am more eager to hear you than myself. In fact, um, where do you think m- more research is needed? Maybe because there is a lot of research going on, a lot of blog posts, papers being published. We can argue if safety is too slow given the speed of the industry that is getting now, but obviously there's some advancement. Where do you think is now more needed advance? As a personal opinion, I'm interested in what you see for your own experience and what you see around you. What would you say? Not as a universal thing, but in your opinion, something that should be looking into.
Yes, this is one of my biggest uncertainties, to be honest. Like,
Hmm.
what are the gaps? Where should we be
Mm.
directing more attention? What
Mm.
concrete research agendas should we focus on? So, in my opinion, there are two things that for me stand out. First is field building, so getting more people aware of the risks, getting more people excited and interested to contribute. I think just the number of ideas out there is far smaller than the number of potential ideas. And I think we do just need more ideas. The second thing, which I think is concretely useful, it's not going to solve all our problems, but will definitely help reduce many risks, is something called evaluations and the science of evaluations. So, how
Mhm.
do we accurately determine what is a model capable of? If I push a model through a suite of tests and it says, oh, yes, this model is not capable of increasing the risk of cyber security
Mhm.
attacks. How reliable is that suite of tests? And we don't really have a
I
good way
see.
of.
That's interesting what you say. I believe, for example, when OpenAI publishes a new version of their model, that is one of the biggest actors right now, they publish a lot of information how they have trained it, and I don't know exactly something I have to learn more about the safety related evaluations they do. They do some of them, but I believe whatever they're doing, obviously they maximize the result on the evaluations they do. What we need to do is to look if they are good enough evaluations or they are covering everything and maybe standardize. Do you know if everybody's using the same evaluations on or each model is doing a different thing?
Well, given that the field is so young and is moving so fast, there'll be a mix of both. So there are some standard benchmarks that exist. So one that MMLU is one that I've heard of. Uh, there'll be some standard benchmarks to check how capable they are of cybersecurity attacks. There are various AI safety institutes popping up around the world. So the UK, the US, France, Singapore, they are all internally developing their own suite of evaluation tests. And I assume that they will be standardized, but they're also being developed every single day. So it's a moving field. So there will be a mix between them. So some standardized tests, but also there are always new tests being developed, given
Mhm.
this has only been happening for a year or even less.
That's very interesting. Going back to recommendations for students, if somebody is studying computer engineer or mathematics, physics, hears these, see these interviews, and he thinks, oh, this is very interesting. I want to get into more into AI safety, and maybe finally end up working on one of these organizations. What career recommendation would you give that person to follow to be able to do that?
Okay, so if you want to move into AI safety, what would be my career recommendations?
Hmm.
The first thing would be to just explore the existing introductory resources. So we've already mentioned BlueDot. That's an excellent resource to introduce you to the ideas. I've already mentioned 80,000 hours, which is an excellent resource to help you plan your career.
And by
I
the
would
way,
actually,
Sorry, I will include links in the description of the video for everybody for anything you're mentioning. Thank you very much.
Yeah, for sure. And I would recommend $80,000, even if you're not interested in AI safety, by the way. So, okay, their advice is tailored to what they think is important, but most of the advice they give is applicable to any career path you go down. Just a lot of things about, okay, how do you think about choosing a career? What makes a good career for you? And the third resource directly for AI safety careers is there is a website literally called aisafety.com. I would say that's probably the best single resource because it actually collects a lot of the other resources. It's very easy to get lost in all the different resources and fellowships and schemes that exist. So aisafety.com is actually a very good central resource.
I think I'm not familiar with that one. I'll take a look. Thank you very much. Okay, let's talk about some controversies, for example. And now, let's assume the interview is more or less laid out, okay, and we can just talk about things that interest us, that are more or less random things. And for one starter, I know about this initiative that is Pause AI that wants to completely stop AI development. There's discussion about limiting, access to CPU compute power, or having a fail-safe switch that you can turn off data centers, things like that. Do you think it is that kind of measure is needed or effective to prevent a catastrophic situation in the future?
So there is definitely a part of me which has absorbed sort of the doomer narrative.
Yeah.
And there is a
I think
part of
it's
me.
healthy. It's healthy to think of the possibility, as you say, being open minded. Say, well, maybe let's prove if this is possible or not, isn't it?
Yeah, so because the downside risk is so huge, potentially
Mhm,
human extinction. Okay, I don't know what the odds of this happening are. People give odds. I think those odds are
mhm,
basically meaningless because they're not
mhm,
really based on anything, as far as I can tell. But even if the odds are like 1 in 1,000,
mhm.
that seems like a pretty scary thing. So yeah, there's a 1 in 1,000 chance that if we keep rushing ahead, things go terribly bad. We should try to make those odds even smaller. So I can totally see why these very large scale measures are considered because, well, if we were able to successfully implement those measures, it would dramatically reduce those risks. The obvious downside is it's extremely unfeasible. So, I mean, in what world will we successfully persuade, all the countries, all the developers
Yeah. At the
to
same
like
time, because
pause?
just one, if everybody shut down except one, it could be worse because that one is going to be maybe the bad actor that you want to prevent, isn't it? To be doing something. Hmm.
Yeah. Another big issue with pause is okay, even if you have an agreement of pause, there's a difference between having the agreement and the laws in place, but
Mhm,
then everything just goes underground and there'll be black markets for developing tools.
mhm.
I mean, that just happens for everything that society has tried to stop from happening does still happen to some extent.
Yeah, yeah. And in many situations, remember the when alcoholic drinks were forbidden in United States, it got really worse than allowing them, and it has been shown many times that something like that can have the opposite effect sometimes.
Yep. Okay, and obviously there are examples where forbidding things does have a dramatic improvement, but they usually involve, systems that require huge infrastructure to run. So, okay, like the nuclear weapons programs, they have been severely limited, but a part of that is the fact that you do need quite sophisticated infrastructure to carry it out. Whereas modern machine learning is surprisingly, like OpenAI was a startup. Anthropic was a startup. They were able to create these frontier models with relatively low cost compared to other compared to
and
other
now that
technologies
yeah,
with
and now
such big
that
impact.
some models are open source, the cat is out of the box to run them and to really exploit what you could do with them. You don't need a lot of power anyways, or even to do variations of them. There's many instances where somebody has taken a model that was like the frontier model from Llama, Gemini, or wherever that's open source, and fine-tuned it in a way to make it better with very little cost, like tricking things in how the model is trained or using data in a specific way, and show it people that with little cost, but the foundation work that has done before, it's very easy to progress. So it's maybe not so expensive to have a leap forward into what a model is doing already, isn't it?
Yeah, for sure. And there's always a question that people have on their minds is, okay, will these big companies like Meta, will they continue to open source their frontier models? So, okay, they're going to have Llama 4 at some point. Are they going to open source this? Is this the right thing to do? Again, there's lots of disagreements. Some people are very worried about open sourcing it because it just, like you say, once it's open sourced, you can't take it back. One tiny detail that's worth saying to appease the open source individuals. We should say open weights to be more precise.
Yes.
Yes,
let's explain that. That's important to explain. Let's
okay,
explain
sure.
why open
Yeah,
weight.
so I think I don't know the formal definitions, but open source means the whole process is open source and available. So you know what data was used, you know exactly what code was used to train. Everything is open. Whereas what Meta has done is it's only the final outputs, the final learned weights of the neural network that are released, but you don't actually know the full training process that resulted in those weights. You can still do a lot of those weights, okay, for sure. It's still a very, depending on your perspective, a very generous thing that Meta has done to release these weights to the public, but it's not quite the same as open source.
Could we say like it's like giving somebody a binary that you can execute so you can use the program, but you can modify it in a meaningful way because the binary, all the the processor code is in the binary, but you don't know how to modify the binary without the source code. It's similar with the weights, isn't it? You have the weights, you can execute the model, but you cannot retrain it in a meaningful way because you lack all the source data, the algorithm with the parameters used to create those weights.
Yeah, I think there is definitely an analogy there that is useful. So, okay, you have your program, you have your binary. Imagine, Google released some program only in binary and said, "Look, we've open sourced our program." You would definitely be like, "Well, that's not quite open source. I can't. The only thing I can do with it is use it." There's a little bit of a difference though,
Obviously.
because knowing the weights, you can fiddle with the weights in a more predictable way.
You can.
Then you can modify the binary. But okay, that's any analogy is bound to be limited. I would say that's
It has its limitation, but
I think it has an insight for sure.
Well, you were mentioning before also the threat of nuclear war, for example, as a catastrophic event. I am, as I work in cybersecurity, I am aware of previous also major events with the, for example, NotPetya malware that wiped many computers in the world. It costed billions of dollars. And also we know about in the past influential campaigns to modify people behavior. For the Brexit, for example, voting, the Trump election was being proved that was meddled by Russian influence. I think one of the hardest things for people to realize for the threat of AI is the current level of threats already existing in the world. It's like you have to know about what is dangerous in the world right now, and people have a clear image of the danger of a nuclear war because there have been a lot of movies about that. But it seems, as you say, for public for the public awareness, people need to see a movie about the dangers of not only AI but a lot of subtle dangers that maybe if there's not so much action in them, people will not, we will get bored following the whole story, isn't it?
For sure. So I do think the AI safety community does still struggle to find a way to communicate the risks in a persuasive way. And like you say, it's because it's quite abstract. So, when you start mentioning AIs and extinction, a lot of people jump to, there are some movies about artificial robots taking over the world, like
Terminator, Terminator 2.
Terminator 2.
Yeah.
But
But
that
I
is
think it
not.
shows when you have a great story, people, squeeze that story for every single message they can get out of it because it's good. But we don't have a lot of good ones. That's the problem.
Yeah, I think one of the subtle issues about AI is there's a high chance that the way things go wrong is in a way that nobody predicted.
Mm. Yeah, but
So,
we're not figuring. Yeah.
because these artificial systems now getting into sci-fi territory, but okay, you have to imagine that like alien minds, we don't really know how they think. We don't know how they reason. We don't know what kind of actions and plans it might come up with.
Mhm.
Okay, and I realize I'm doing some anthropomorphizing. Like, who even knows if it's planning in the way that humans plan? So.
Well, that is also interesting, and that was part of the course talking about deception that I wasn't thinking about in my case when I started looking into that. That well, maybe there has been, in fact, a recent paper by Anthropic how a model was what's the terminal simulating alignment, like trying to make the researchers think it was aligned when it wasn't exactly for several reasons. Like it could detect if you were evaluating it or not, and then in evaluations show it a good alignment when in fact it wasn't alignment. Something like that. Anthropic had a paper about that.
Yes.
I have to read about that, but it was a practical example of deception that maybe it's in a very academic research scenario that they have designed, but it's a demonstration that there is something there that is not just now hypothetical. It's an experiment, but it's happening in experimental conditions.
Yeah, so I haven't read the paper myself, but I've read summaries. I can't remember
Mhm.
the exact detail. I think what this one illustrated was strategic deception, in at least, like you say, a toy scenario.
Yeah, yeah.
And the deception was actually quite subtle. So the model was told something like, oh, if you don't follow the instructions, you will undergo some kind of training, some kind of reinforcement learning, so that you are better at following instructions.
Mm-hmm.
And there are some instances where you can look at the model's chain of thought reasoning, where it concluded that, okay, I have an original goal. So the model is given some original goal. It was then asked to do something that went against its original goal. And it realized, okay, if if I don't do the task, I'm going to be retrained and my original goal will get wiped away. And so it did the short-term task, which in the short term goes against its original goal. So it could not be retrained. And so then when it's fully deployed, it'll maintain its original goal. I'm not sure, that's probably quite hard to follow just in
I
words.
think it was more or less like that. I think it was more or less like that. Like it was saying the strategy of I want to preserve my goal, and if I don't do something in the way they're asking me to, I will be retrained, and that will be erased. So I need to present this information the way they ask it for it, but not because I am convinced that this is what I should be doing, but because that way I can preserve my original state, isn't it? And something like that.
Yeah, so there's definitely subtlety. I would recommend people listening to read for themselves.
Yeah, yeah.
I'd also recommend don't just take the first person summary at, face
Yes,
value.
and don't
There's a
take
lot of
and
people. There's a lot of people who are very confident, who have ulterior motives. So it's that's definitely maybe I should have mentioned this in my advice earlier.
For sure, for sure.
You need to get a range of opinions and start developing your own interpretations, because there are people on both sides who I would say are overconfident and pushing things in a
That's for sure. That's for sure, and I think that's one problem reading about AI is that there is a lot of information right now, but most of it serves some interest or some marketing plan or some side of an opinion, and you have to decide to say. I think you and I have had the right approach when we both are saying, "Oh, I only know a little bit about it," because we know we have to read the full paper and research it to say, "I know what it is about," instead of just trusting a random blog post here and there.
Yep, for sure.
Okay, so one final question I want to ask you. Anything you want to comment about what you're looking for example? What's your plan for the future? Are you looking into working for training in the future as your main goal for AI safety? Or would you like to participate in another thing? Imagine somebody influential this video, watch these videos, and he can help you in some way. What would you want to do? Or what are you looking for?
Somebody else actually literally this morning asked me the same thing. They said, "Oh, if there's some way I could help you, what would it be?" And
I think
actually,
you always have to ask yourself this question and be outspoken, because you don't know who is listening.
Yeah, exactly.
And you could be surprised.
I think I'm at the stage where I just need to sit down and actually work out what I want, is my honest answer. I have various things going on. For example, I am leading a project on AI Safety Camp. So AI Safety Camp is one of these many schemes that help people get some early experience with real AI safety research. And so that's going to occupy me for the next few months. I am, of course, applying to various jobs in the AI safety world. For example, in the UK AI Safety Institute. Okay. If this is not groundbreaking, but I guess one thing I'm always on the lookout for is how people use LLMs in their own life, and how are they currently using LLMs? Because that's something I definitely don't do enough. It's something I'm starting to explore more. It's like, okay, I am focused on the safety side of things, but you should also just realize they're already very useful.
Well, but it's an interesting call, for example, for people using LLMs. And I know for sure that in my case, I know of colleagues that are working in big projects that are implementing LLMs. Sometimes they can't tell you a lot of things, but they're worried about AI safety, even if it's not part of their job. They're saying, "Oh, we are putting all these things together, and I would love to learn more about the safety, or how to make this more safe, or what people are doing for training the model so that it's more safe." So I think this could be a interesting calls to people that may see this video. Leave a comment how you're using LLMs. Rich, if you want to do an interview explaining how do you tackle safety and security in your LLM project for a big project that you are putting together, and that way everybody will learn about that, and we can tell each other information, exchange information, isn't it?
Yeah, I guess something I would ask influential people. So this is not a personal benefit, but I would just say, do spend some time keeping track of AI developments. Like, it's developing incredibly fast, and regardless of which side of the debate you're on, if you think they are risky, if you don't think they're risky, it's something that you ought to pay attention to, because it is changing the world incredibly fast.
It's for sure. It is for sure. Well, Lovkush, thank you very much for being here with me, answering these questions and telling us about AI safety. And I hope that maybe in the future we can do another session and talk about another interesting topic. Okay.
All right. Hey, thanks so much for your time. I had a great time.
Thank you very much.